everyone. Today we're going to be talking about something we call particle in motion problems. This kind of goes back to our conversations in the last couple of sections about position, velocity, and acceleration. So we just want to talk a little bit about when an object is speeding up and slowing down and at rest. And then we're going to be looking at a graph, and then we'll look at an algebraic problem. So we can say that an object is speeding up when the signs of the velocity and acceleration are the same. So an object is speeding up when the signs of velocity and acceleration are the same. So they could both be negative or they could both be positive. On the other hand, an object could be slowing down when the signs of velocity and acceleration are opposite. Meaning one of them is positive and one is negative. And the last thing that we need to talk about, which I think we've actually talked about a little bit before, we know an object is at rest when the velocity is 0. Or in other words, v of t is equal to 0. So we'll look at a graph of a velocity function, and we'll kind of talk about the pieces and how we can find out information from the graph, and then we'll look at a couple of algebraic examples. And what we're going to be introducing here are something called sign charts. And sign charts will definitely come back in our next chapter as well. So if we feel comfortable making sign charts, doing what we do with particle in motion problems, that will help us when we're talking about concavity and intervals of increasing and decreasing in chapter 3. So this particular example is showing us a graph of velocity. So specifically, we need to make sure that we're kind of taking a look at the type of function that is being graphed. So this one is velocity. We want to know on what intervals is the object speeding up, what intervals is the object slowing down, and when is the object at rest. So if this is our v of t function here, we need to first identify where velocity is positive, where velocity is negative, and where velocity is 0. So we're going to be looking at this in terms of its relationship to the x-axis. So if velocity, or if our v of t function is above the x-axis, well, that's telling us that our velocity is positive. So I'm going to make myself a little sign chart here, and I'm going to label this as v of t. And when I talk about a sign chart, I'm really talking about kind of like a modified number line almost. And the way that I modify it is I literally look at what my numbers are here along my x-axis, and I put them on my number line over here. So here we're starting with 0. I'm just going to make little tick marks here for all of my numbers along my x-axis here. And it looks like we're ending at 8 here. So here's my ending place. And I know that the velocity is positive from 0 to 2 because that part of my graph is above the x-axis. So I'm going to put kind of a little line here at 2, and I'm going to make a bunch of pluses kind of above my number line, indicating that the velocity is positive between the x values of 0 and 2. And we also know velocity is positive from the x value of 6 to the x value of 8. So I'm going to make myself kind of a little vertical bar here, and I'm going to put a bunch of pluses over here as well. So that's telling me that my velocity is positive or above the x-axis from the x value of 6 to the x value of 8. But then we know that the velocity is below the x-axis between the x values of 2 and the x value of 6. So this is actually telling us that velocity is negative, and that's because it's below the x-axis. So v of t is negative down here. V of t is positive up here. And we also know one other thing. So it's going to be asking us about slowing it down and speeding up, which means that we need to compare our signs of velocity and acceleration, because it's telling us that that happens when we need to look at the signs. Either they're going to be the same or they're going to be opposite. But it's also asking us when the object is at rest. Well, we know that the object is at rest when the velocity is 0 or v of t is equal to 0. Well, that's actually happening in two places on this graph, because the velocity at some point needs to change from positive to negative or from negative to positive. And the times that that's going to happen is where v of t is equal to 0. So on the x-axis, our v of t is 0. So right away, we can actually answer this part of the question. When is the object at rest? The object is at rest at two places, at the x value of 2 and the x value of 6. And actually, it's time that we're talking about here in terms of the x-axis. So we're saying that at time, t is equal to 2, and time t is equal to 6. And that's because that's where our velocity is 0, or that's where our velocity is on the x-axis. Okay, so we know information about velocity. We know when it's at rest. We know where it's positive and where it's negative based on where it is on the x-axis, whether it's above or below. But we also need to talk about the acceleration. Well, we know that the acceleration is the derivative of velocity. So a of t is the derivative of velocity. And remember that when we're looking at derivatives, we're looking at slopes. So if I'm reading my graph left to right, I see that there's two different slopes going on. I definitely have a negative slope and I definitely have a positive slope. So that actually reads for my a of t. I know what the acceleration is going to be, or the sign of acceleration, because I know where my slopes of my tangent lines would be negative, and I know where my slopes of my tangent line would be positive. So I'm going to make some marks for my a of t function. I'm going to put them below my number line here. And the first thing is I'm going to divide where my a of t is changing. Well, I know that my slope is changing right at this point, because my slope is changing from negative to positive at this point, and that's at x is equal to 4, or our time of 4. So what I'm going to do here is I'm going to divide my a of t function right where my slope changes, which is going to be at 4. And then I have to determine, well, if my slopes are negative from 0 to 4, I want to make my marks of a of t all in here as negatives, because that's where the slope of the tangent lines would be negative, or the slopes of the velocity function gives us the acceleration function. And then my slopes are going positive, or my slopes of my tangent lines are going to be positive from 4 to 8. So I'm going to make a bunch of pluses here telling me that my acceleration, or my slopes of my tangent lines, are positive from 4 to 8. And then I can go ahead and compare my signs. And the reason that I like putting these kind of divider marks in is because it makes it easier to really kind of divide up where you compare your signs. And what we're going to be doing is we're literally going to be looking at the positives and negatives between velocity and acceleration. So if I look from 0 to 2, my velocities are positive, but my accelerations are negative. So from 0 to 2, this is telling us that since the signs are opposite from here and here, our object is actually slowing down. So I'm going to break this apart into some intervals. So I know that I'm slowing from 0 to 2. And then if I look at kind of the next kind of dividing chunk here, that's from 2 to 4. And I see that my velocity here is negative, but from 2 to 4, my acceleration is also negative. So since these are both negative signs in between this interval, this is actually telling us that our particle, or our object, is speeding, because the signs are the same. So I know that I'm speeding from 2 to 4. And usually I just write these as kind of like intervals or inequalities here. And then I'm going to take a look at my next chunk. Looks like my next chunk's from 4 to 6. My velocity is negative. My acceleration is positive. These are opposite signs, so that means that I'm slowing again. And then my next chunk is from 6 to 8. I've got positives on velocity. I've got positives on acceleration. These signs are the same. They're both positive. So that means that I'm speeding on the interval from 6 to 8. So this is why it helps to get the sign chart so that you can kind of organize your work, and it really shows you where your positives and where your negatives are. So when you have to go ahead and compare your signs, it's right there in front of you. So let's take a look at just kind of a quick calculation problem. So here it's telling us we want to let v of t, our velocity, be 1 over pi plus sine of 3t. And I want to use this to write the acceleration function. So I know that the acceleration, again, is the derivative of velocity. So if I take the derivative of 1 over pi, that's just 0 because that's just a constant. And here I'm going to need to use the chain rule because I really have an outer function of sine and an inner function of 3t. So my outer function derivative is going to be cosine, keep the inside stuff the same, multiply by the derivative of the inside, which would just be 3. So I'm going to write that a little bit nicer. My a of t function would be 3 cosine of 3t. And then it's asking us at specifically the time, pi over 4, I want to know is the object speeding up or slowing down. So this is where I need to, again, compare the signs of the velocity and acceleration. So that means that I want to evaluate velocity at time pi over 4 and acceleration at time pi over 4. So let's do v of pi over 4 first. So my velocity is 1 over pi plus sine of 3 times pi over 4. So that's really going to give me 3 pi over 4. And then I just want to calculate what the sine of this is going to be. So 1 over pi plus sine of 3 pi over 4. This is a unit circle value. So if you need to get your unit circle, I definitely would do that. This is the second quadrant here. So that's going to tell us that our sine is going to be, I think, positive root 2 over 2. And this whole quantity is positive. A positive number plus a positive number is going to give us a positive number. And again, we're not really worried about what the number is. We just want to know about the sign. So then let's do the acceleration at pi over 4. So a of pi over 4. So 3 cosine of 3 times pi over 4, again, is just 3 pi over 4. And again, that's in our second quadrant. This is a unit circle value. So I'm just going to take my 3 and I want to multiply it by the cosine of 3 pi over 4, which is going to be, I think, negative 1/2. I'm sorry, negative root 2 over 2. And that's going to give us negative 3 root 2 over 2, which is obviously a negative number. So since the velocity is positive and the acceleration is negative, this is telling us that the object is slowing because these signs are opposite. The object is slowing since our v of t and a of t signs are opposite. So again, we really weren't worried about the number of these. We just wanted to know whether it's going to be positive or negative. And then we wanted to just compare it to determine if we're speeding or slowing. All right, so now we're going to answer a couple of different questions. These are kind of the most commonly asked questions you're going to see about particle in motion problems, which is just an object in motion. In this case, it's me. So I move at the front of the classroom holding my coffee back and forth, back and forth. Sometimes I stop. And it's telling me that I'm moving according to the law of motion. So this is a position function, S of t. And I want to answer a bunch of questions about this position function. The first thing I need to know is, well, when am I going to be at rest? Well, remember that we're at rest when v of t is equal to 0. So first thing I need to do is I need to get the derivative of this position function to figure out my velocity function. So I'm first going to find v of t. So that's 3t squared minus 12t plus 9. And I need to set that equal to 0. So I'm going to go ahead and say, okay, 0 is going to be equal to 3t squared minus 12t plus 9. And then I'm going to do whatever I need to do to solve this. First thing I notice here is they have a common factor of 3. So I'll go ahead and factor that out. And then it does look like I can go ahead and factor this. So that is factored into t minus 3 and t minus 1. And then that gives me 2 times here when I set t minus 3 equal to 0 and t minus 1 is equal to 0. That tells me that Miss R is at rest at t is equal to 3 seconds and t is equal to 1 second. Because again, that's just taking these two quantities and setting them equal to 0 to solve for t. So what I'm going to do with this information is I'm going to actually go ahead and set myself up a sign chart. So wherever you want to do that is fine. I'm going to set it up kind of right in this gap here. And I'm going to start at 0 because it's telling me that in my explanation up here, time is greater than or equal to 0. So my time's going to start at 0. And I'm just going to kind of go ahead and make a couple of tick marks here just to kind of mark in some times. And what I'm going to do is I'm actually going to make some markings at t is equal to 3 and t is equal to 1. And I know that this is going to be gathering information about velocity because that's the function that I'm working with here. So I'm going to make a vertical bar at t is equal to 3 because that's where my velocity is going to be changing. And I'm going to make a vertical bar at t is equal to 1 because, again, that's where my velocity is going to be changing. So what I want to know is when am I going to be moving in a positive direction? So what I need to do in order to do that is I need to determine when is v of t positive. So in our sign chart, that's going to be where are the pluses? And here, what we need to do to determine where the pluses are is we need to use the intervals that we just broke up from these time values. So what I'm going to do is I'm going to write an interval. My first one is going to be from 0 to 1. My second interval is going to be from 1 to 3. And then my third one, I don't really know where this number line ends because time is going to continue on. So I'm going to say that my last interval is going to be anything greater than 3. And what I need to do is I need to determine in these intervals, is it going to be plus or is it going to be minus? Is velocity positive or is velocity negative? So what I'm going to do in these intervals is I'm going to pick a number between 0 and 1. I'm going to pick a number between 1 and 3, and I'm going to pick a number between, anything greater than 3, and I'm actually going to plug it into the velocity function. So here, I'm picking a number in the interval. Again, these intervals are set up from our velocity information up here, and I'm going to test in the velocity function to determine if it's positive or negative. So from 0 to 1, I'm just going to pick something relatively easy. So I'm going to pick 1/2. And I'm actually going to use my factored form of the velocity function. I'm going to use this 3 times t minus 3 times t minus 1 to test. So 3 times t minus 3 times t minus 1. And I'm just going to plug in some numbers here. So I'm going to carry down the 3. I'm going to plug in the 1/2 where the t is. So it's going to be 1/2 minus 3 times 1/2 minus 1. And what I'm going to do for each one of these quantities, I'm just going to determine is it going to be plus or is it going to be minus? So 3 is obviously positive. When I do 1/2 minus 3, that gives me a negative number. And when I do 1/2 minus 1, that also gives me a negative number. So what this is asking me to do is take a positive times a negative, and that gives me a positive number. So in this first interval, I've now shown that my velocity is actually going to be positive. So I'm going to go back up to my sign chart up here, and I'm going to put some pluses indicating that I have positives in between there. And that's what I'm going to do on every interval. So from 1 to 3, I'm just going to pick something in between there. So I'm going to pick 2. And again, I'm just going to use my factored form. So 3 times 2 minus 3 times 2 minus 1. Again, 3 is positive. 2 minus 3 when I do that is actually negative. and 2 minus 1 is positive. So a positive times a negative times a positive just gives me a negative. So this is telling me that in this interval, my velocity is negative. So I'm going to go back up to my sign chart and I'm going to put a bunch of minuses in between here. And then I'm going to do the same thing for anything greater than 3. So I'm just going to pick, I don't know, 4. And again, just plug into my factored form up here. So 3 times 4 minus 3 times 4 minus 1. 3 is positive. 4 minus 3 is also positive. 4 minus 1 is also positive. So positive times positive times positive gives me positive. So my interval, anything greater than 3, velocity is positive. So I'm going to go ahead and just go back up to my sign chart up here and say that's all positive. And then I can finally actually answer the question. So there's 2 intervals where I'm moving in a positive direction. The first interval and that last interval. So Ms. R moves in a positive direction. On the interval from 0 to 1 and anything greater than 3. If it was asking where I'm moving in a negative direction, that would obviously be in that center interval from 1 to 3. So then it's asking me find the total distance traveled in the first 8 seconds. So if we're talking about total distance, this is actually indicating that we want to use the position function. So we're going back up to that cubic function that we were given at first. So we're using the s of t is equal to t to the third minus 6t squared plus 9t minus 2. And what I need to do is I need to actually, in this position function, test the first value, which is always going to be 0. I want to test the last value, which in this case happens to be 8. And then I need to test the values that I ended up getting in the first part of this function. So I need to actually test where the velocity is changing. So I need to test t is equal to 1 and t is equal to 3. So first, last, and then any values where your velocity is changing. So what I need to do is I need to set up, well, what is the position at the time of 0? What is the position at the time of 1? I'm just going to go in kind of numerical order here. What is the position at the time of 3? And then what is the position at the time of 8? And I'm just going to take this number and I'm going to plug into my position function. So 0 to the third power minus 6 times 0 squared plus 9 times 0 minus 2. And that's going to give me an initial position or my starting position of negative 2. And I'm going to do that for every single one of these values. So 1 to the third minus 6 times 1 squared plus 9 times 1 minus 2. So that's really 1 minus 6 plus 9 minus 2, which I think gives us 2. S of 3 is going to be 3 to the third minus 6 times 3 squared plus 9 times 3 minus 2. So 27 minus 6 times 9 plus 27 minus 2 gives me negative 2. And then I'm going to do 8 to the third minus 6 times 8 squared plus 9 times 8 minus 2. And again, I'm just using my calculator to kind of do these calculations a little bit quicker. I think that gives us 198. So what I need to do now is I need to think about these as being like numbers on a number line, and I need to actually figure out how many units I would be moving to get from like a number of negative 2 on a number line to a number of positive 2 on the number line. So if I'm moving from negative 2 to positive 2, I'm traveling a total distance of 4 units. To get from negative 2 to positive 2, I'm traveling 4 units in between. And then if I want to go from 2 to negative 2, I'm actually traveling back another 4 units because I'm going backwards on the number line. But in this case, remember that distance is always going to be positive. So even though you're going left on the number line from 2 to negative 2, you're still going a distance of positive 4 units. And then to get from a -2 on a number line to a positive 198 on a number line, you're actually going to be traveling a total of 200 units. So to get the total distance, you're actually taking a 4-unit, and a 200-unit distance, and you're going to actually add those together. So total distance here is a total of, I think that would be 208. And actually our units are given to us up here as feet. So total distance is 208 feet. Okay, so now what we need to do is we need to illustrate the motion. So this is actually called a snake graph. And what we're going to do is we're going to take these values that we just calculated in part C. So we're using positions from part C. And we're going to actually set up another number line using those distances. Or using those positions, I should say. So I'm going to make myself a little number line here kind of at the bottom because I'm going to actually draw my graph above it. And I'm just going to list these in numerical order. So I see that I have -2, I've got a +2, and I've got a positive 198. And what I'm going to do is I'm going to go in order. So I'm going to start at my time of 0 up here. So at my time of 0, I was at a position of -2. So I'm going to make myself kind of a little dot here and say, okay, this is where I'm starting at a position of -2. And I'm also going to label the time here as 0. And then what I need to do is I need to show the motion. So from 0 up to the position of at time is equal to 1, I'm going to the position of 2. So I'm saying, okay, at 0, I'm over here. At the time of 1, I'm actually over here. And I've traveled this way to the right. So I'm going to go ahead and put some arrows saying, okay, I traveled from here to here. And when I end up here, my time is at 1 second. So that takes care of this, and that takes care of this. And then we're saying, okay, at the time of 3, I'm not now going back to my position of -2. So I'm not going to go directly back here. I'm actually going to kind of snake my graph upward and say, okay, now I'm going back to the position of -2, but now I've traveled backwards. So I'm going to make myself some arrows indicating that I've traveled kind of back to the left here. And this is where I'm ending at my time is equal to 3. And that information is coming directly from here. S of 3 is -2. At the time of 3, my position is -2. So I'm going to go ahead and indicate that on my graph. But then we're saying, okay, that's happening at time of 3. At the time of 8, my position is at 198. So I'm going to say, okay, from here, now I'm traveling this way. My position is at 198, and my path is going to look something like this to get there, because now I'm traveling on my number line to the right. And I'm ending up here at time is equal to 8 seconds. So all of this information from your graph is taken from this part of your problem. You know what your positions are at the time starting, at the time ending, and at the time where your velocity is changing direction. And here's our snake graph. Okay, and then we have a couple more questions to answer. Now we want to know about speeding up. So speeding up, now we have to compare our signs of our velocity and our acceleration. So now we need to know something about acceleration. So first thing I need to do here is I need to find what A of t is. And we know that the acceleration, again, is the derivative of the velocity function. So we said that the velocity function was, I'm going to write it up here, v of t was 3t squared minus 12t plus 9. So the derivative of that would be 6t minus 12. And what I want to know is, now that I know my acceleration function, I need to know where the acceleration is changing, because I need to know on my number line or on my sign chart, I need to know where to put that vertical bar. Where am I going to say that my signs and my acceleration are changing? So I'm going to say find where A of t changes. sign. And that's going to be where a of t is equal to 0. So this acceleration function that I just wrote up here, I'm going to set that equal to 0, solve for t. So if I add 12, that gives me 12 is equal to 6t. That tells me that t is equal to 2 is where the acceleration is changing. So that's where it's going to be changing either from positive to negative or from negative to positive. So then I'm going to go ahead, I'm going to say, all right, well, now that I know where it's changing signs, I'm going to go back to my sign chart from my first side here. And now I'm going to fill in information down below it about a of t. And the first thing I know about a of t is it's changing signs at 2. So I'm going to go ahead and put my vertical bar here at 2. And then I need to do something similar to what I did over here. I need to know about the signs of the acceleration. Is it positive here or is it negative here? Is it positive here or is it negative here? So I've just set up 2 intervals on my a of t, 0 to 2 and anything greater than 2. So I'm going to set up my intervals here. My intervals are from 0 to 2. And my interval is anything greater than 2. And what I need to do on those intervals is now I need to determine what is the sign of the a of t going to be. Is it going to be positive or is it going to be negative? So I'm going to, again, pick a value in the interval, but this time I'm going to test it in the a of t function. So for this one, between 0 and 2, I'm going to pick a t value of 1. And I'm going to plug it into my acceleration function, the 6t minus 12. So 6 times 1 minus 12 gives me negative 6, which gives me a negative number. So that's telling me that on this interval from 0 to 2, my acceleration is negative. So I'm going to go ahead and mark my negatives in here. And then I'm going to do the same thing on this interval. I'm going to pick a number that's greater than 2. So I'm going to pick 3. And I'm going to plug that number into my acceleration function. So 6 times 3 minus 12 gives me 18 minus 12, which is a positive number. So that's telling me that anything greater than 2, my acceleration is going to be positive. So I'm going to put a bunch of pluses here. And then I can finally answer my question. It's asking me, where am I speeding up? So I'm going to go ahead and compare my signs. Well, it's not going to be from 0 to 1 because my velocity signs are positive, my acceleration signs are negative. But if we look at the next chunk of values between 1 and 2, velocity is negative, acceleration is negative. So that's going to be one of the intervals where I'm speeding up. So from 1 to 2. So my speeding interval is going to be from 1 to 2. And if we go back and look at our next chunks, 3 to 4, velocity is positive, acceleration's also positive, and everything actually greater than that is also going to be positive. So same signs, anything greater than 3, we are also speeding. And I know that I'm speeding up because the signs in these intervals are the same from velocity and acceleration. And then the last question we want to answer about this is, when is the speed constant? That's actually where a of t is equal to 0. And we actually already knew that. We did that above. We actually know that that's going to happen at t is equal to 2. So I'm going to say my work is above here. And then the last thing we want to answer about these particle and motion questions is just kind of another computational problem that you might run into. It's telling us again about the position function. We want to know the particle's acceleration each time the particle is at rest. So we're ultimately looking for a of something. So again, I'm going to go ahead and just figure out, all right, well, if I'm looking for acceleration, I need to first figure out what my velocity function is from position, and then I want to figure out what my acceleration is going to be from there. So b of t is 3t squared minus 12t plus 9. A of t is going to be 6t minus 12. And if we notice, these are the exact same functions that we were just working with in the last problem. So we knew that we were at rest when v of t was 0. And we know that that happened at time 1 second and time 3 seconds. And then what we want to do is, now that we know that when we're at rest at these two places, we need to figure out what the acceleration is going to be at t is equal to 1 and t is equal to 3. So that's what this is asking us to do. So find a of 1 and a of 3. So a of 1 is going to be 6 times 1 minus 12. So that's going to be negative 6. Acceleration here, we're going to want to use units. So acceleration would be negative 6 feet per second squared. And a of 3 is 6 times 3 minus 12. And that's going to be 18 minus 12, which is going to give us a positive 6 feet per second squared. So our acceleration when our velocity is 0 is either negative 6 feet per second squared or positive 6 feet per second squared. So now I'm going to have you guys try some problems for homework. Let me know if you have any questions.